Welcome to clickmyproject.com. The title of this paper is Low Energy Online Self-Test of Embedded Processors in Dependable WSN Nodes. This comes under the domain Dependable and Secure Computing. Now I am going to explain the abstract of this paper. This mainly deals with the internal processes of nodes which are placed in the wireless sensor network. What is meant by wireless sensor network? It's nothing but a network which consists of number of nodes which are connected through signals and not through the cables. These nodes are often placed in harsh environments. Hence, there may occur some intermittent faults due to some environmental hazards. These faults have to be checked often. Thus, two testing techniques named online and in-field testing were emerged to guarantee the correctness of the operation. Along with this test, the processes integrated in the WSN nodes are also be tested for minimum energy consumption. This is needed because the WSN nodes does not operate with any external power supply. It operates only with the battery. Hence, there is a need for these nodes to take less energy. For measuring these criteria, software-based self-test has emerged as an effective strategy for online testing of processes. These software-based self-routines are not reliable also. This software-based self-test is in the form of routines which are executed in the embedded processes. These SBST routines are not initially available in the nodes. These are downloaded from the flash memory which are available in the wireless sensor networks. Hence, the notion of dependability includes not only reliability but also the availability. Thus, in order to encase both aspects, this paper proposed a methodology for optimization of SBST routines from the energy perspective. Now I am going to explain this project in detail. First, it considers the energy optimization methodology. This methodology presented in this paper considers 4 steps. The main steps are carried out with the 3 basic cases. The first case is the SBST routines are located in predefined position in the flash memory of the WSN nodes, and these routines cannot be updated and thus downloading is irrelevant. The second case is the WSN node has some free space in its flash memory and it can be updated a number of times. And the third case is the WSN node does not have any space in the flash memory. So, in order to solve these 3 cases, the SBST routine energy optimization steps are as follows. In the first step of this methodology, the bytes required for the routine in immediate and loop-based coding style are calculated according to the instruction template sizes. What is immediate and loop-based coding style? In routines, there may be immediate instructions that produce immediate results. They are considered as immediate coding style, and loop-based coding style follows some number of iterations. Based on these 2 types of coding styles, we have to perform instruction profiling. Instruction profiling is nothing but computing execution cost, downloading cost and storage cost for each of the coding styles. After calculating these 3 costs, we have to perform summation for both the coding styles. After computing the summation, we have to compare these 2. If the sum of immediate coding style is smaller means, then we need to perform complete loop unrolling. If the sum is smaller for loop-based coding style means, we have to perform partial loop unrolling and loop fusion. These loop unrolling and loop fusion concepts comes under the loop transformation technique, which is the second step in this project. In this step, the loop unrolling is done, which targets the reduction of execution time by reducing the number of times the loop termination condition is checked. This improves the instruction level parallelism. Then we need to perform loop fusion. Loop fusion targets the reduction in the number of times that the loop termination condition has to be checked and facilitates data reuse in registers. After performing all these loop transformations, the third step is instruction substitution. In this, the instructions which have high energy cost are replaced with the instructions that have low energy cost. The final step is the application of register name adjustment algorithm. This algorithm initially considers a pool of registers. From that pool, each register is mapped with the initial routine instructions. After mapping, the registers can be adjusted according to the energy consumed for executing the instructions mapped for the registers. This is the main process carried out in this project. Now I am going to explain the flow of this project. The first one is the template based SBST routines. Here we are taking these routines as our input. Next one is the energy profiling. Energy profiling is nothing but the instruction profiling. In instruction profiling, we will calculate the energy cost. The energy cost will consider three types of cost, that is downloading cost, execution cost and storage cost. These three costs are computed for both the coding styles, that is loop based and immediate based. The summation of all these three is considered as the energy cost. After computing the energy cost, we will compare those two costs. For example, if a loop based cost is lesser than the immediate cost, then we will perform transformation operation, that is loop transformation. Loop transformation involves loop synthesis, loop unrolling and loop fusion. Loop unrolling is nothing but which targets the reduction of execution time by reducing the number of times the loop termination condition is checked. Loop fusion is nothing but it targets at the reduction in the number of times that the loop termination condition has to be checked and facilitates data reuse in registers and cache. If this condition is false, means that is if loop based cost is higher than the immediate based cost, then we will perform complete loop unrolling, that is for reduction of execution time. After performing these two operations, it will come to the instruction substitution phase. In instruction substitution phase, the coding style with highest cost is replaced with the lowest cost instructions. After performing this, register name adjustment phase involves. In this phase, we will perform an RNA algorithm. This algorithm attempts to find registers mapped for each instructions. It will calculate the cost according to the registers, and if the cost of each register is high, means it will replace with the another register that will perform the same operations. After performing all these things, the resultant will be the energy optimized routines. Now I am going to show the demo of this project. For this project execution, we need two softwares, that is NetBeans IDE and another one is the WAMP server. WAMP server access the database. Here we have to start the database initially before running the project. Our project execution starts from the intro.java file and we have to click run file here. We are forming a wireless sensor network here, and we are assuming that we are downloading these routines from that nodes. These are the routines we are taking as inputs, and we are calculating the cost for both the loop based and immediate based coding styles. This shows the downloading cost and storage cost for loop based coding style, and this shows the downloading cost and storage cost for immediate coding style. Finally, we get the execution cost for immediate based coding style and loop based coding style. After performing all this, we have to perform instruction profiling. Instruction profiling shows the overall details of both the coding styles. Here it shows the total and energy cost for immediate instructions, that is total energy cost here is 6,499 and the loop based instruction cost this much. This is the instruction profiling. After this, we have to perform energy optimization, that is loop transformation involves loop unrolling, loop fusion and RNA application. Loop unrolling is executed here. Loop unrolling reduces the number of times it is executed. Before loop unrolling, it takes this much energy, and after loop unrolling, it takes this much energy. This shows that the energy optimization has been done. After performing loop unrolling, we have to perform loop fusion. Loop fusion counts the number of times the condition is to be checked. Totally, the loop instruction is executed 11 times and the energy cost is this much, and it is reduced to this much. After performing this, we have to perform RNA application. RNA application will show the registry instructions, that is the normal instructions which are mapped for each registers. We are mapping it to D, M, Z, Y like this. After performing this, we have to analyze the registry where which we can be substituted. For example, if F is assigned to M, S is assigned to Z and S is assigned to Y. Hence, these operations can be assigned to these registers. Instead of running with M, Z and Y, we can run it with Z, T and T. This reduces the cost than the previously assigned registers. Thank you.